Hi, I'm Joe Reis. Welcome to my talk, Trust by Design, Modeling Reliability into the Modern and AI Data Stack. So let's start off by talking about the trust problem. This is especially important in the age of AI. So let me start with a small confession. I've been in the data and ML game for a very long time. And I got to say, I'm usually skeptical of most things. I think that's part of my brand as being very, I don't know about contrarian, but skeptical is a good way of putting it. So I don't trust that data pipelines or warehouses will work overtime. Things break. I don't trust most dashboards or analysis. It's just a creature of habit, right? And I'm often skeptical of AI outputs. And this last part is especially top of mind in today's world of AI powered BI and frankly, AI powered everything. So you ask a question, the dashboard says one thing, AI assistant says another, and maybe the SQL behind both is, well, let's just say complicated. And we live in the most data-driven moment in history. Yet, from what I can tell, trust in data has never been lower, actually. And so as AI systems and agents make more and more decisions and take actions on our behalf, that lack of trust becomes very dangerous, both for businesses and for society. And so here's the truth. Trust isn't only something you monitor. It's something you need to design. We've learned over the years to design for security. We've learned to design for scalability. And now we have to learn to design for trust. This is a new thing. And the heart and the foundation of that design, the hidden scaffolding that holds it all together, is data modeling. Now, I'm not talking about modeling in the narrow ER diagram or Kimball star schema sense. That's certainly important. But what I'm talking about is modeling in the broad modern sense, where you model the world, you model across systems, different data modalities and meaning, right? This is different than how we did it in the past, but we're in the AI era. Data modeling is no longer just about tables. It's about truth across many forms of data. So let's talk about fragility for a moment, why things break. So it's interesting. Every organization I visit has a stack that looks immaculate on the whiteboard, right? They got maybe real-time data pipelines, a nice cloud data warehouse. You got data catalogs. You have observability. You might have an AI copilot, some agents, and yet the system's reliability is hanging on a thread. And here's why. Small mismatches in meaning become large failures at scale. So one upstream schema change ripples across everything, right? This is historically how it's been, but it's more acute now. One metric definition might drift, and then the AI model amplifies this error at machine speed. A mislabeled training data set quietly becomes a very biased model that impacts real users. And so bad or ambiguous data nudges an LLM to hallucinate and produce toxic answers. We've all seen this. And we keep trying to fix trust with more tooling, right? More monitoring, more alerts, AI validation, eval layers, and so forth. It's all very important, of course. But those tools are fighting the symptoms and not the root causes. They can tell you something that is wrong, but they can't tell you what right is. So let's talk about a quick story here. All right, this might sound familiar to a lot of people. So a consumer app redefined an active user from logged in the last 30 days and sent at least one message in 30 days. Finance updated their forecasting model, and product analytics adopted the new definition. So the AI assistant is trained on both of these different definitions here. And overnight, the report started showing two different truths, right? So the AI happily justified either one, depending on the prompt. It does that. But marketing, right? They see how things are going. They cut spend based on the decline of this metric, while sales celebrated growth. And this mismatch is fairly common, right? The tech wasn't broken, though, right? It wasn't a data pipeline issue. But the meaning of the data, that was disrupted. And when meaning breaks, reliability breaks. So in complex systems, fragility often hides in three places. You have hidden semantics, columns with names like created at that mean 6 different things across teams. Customer, that sometimes includes churned users or maybe not Who knows? You have silent contracts as well, unspoken assumptions like price is always positive or every order has a customer. When these things aren't modeled as constraints, they become optional until you find out that they aren't. So, and then you get temporal drift, right? Definitions that evolve, but the lineage, maybe the documentation, and even the AI prompts, they don't keep up with this, right? So yesterday's truth becomes today's bug. Yesterday's truth becomes today's bug. And these costs, they show up everywhere. Where do they show up? Well, engineering costs is one. Constant firefighting, brittle pipelines that break all the time, cascading rollbacks of the data. You have decision cost, right? You have contradictory dashboards and AI, and it's hard to explain away these narratives. Then you have AI cost, right? Confident, wrong answers, safety filters, overfiring, evaluation scores that wobble all over the place, right? And this ends up hurting truth and trust. People stop believing the systems, and then they build shadow Excel spreadsheets and bring shadow AI into the picture. And put simply, we've built incredibly powerful systems on top of models that barely understand the world they're trying to describe. So monitoring can catch a heartbeat. Modeling defines the anatomy, so to speak, right? So reliability isn't restored by monitoring things more diligently. It's restored by agreeing on what things mean and encoding that agreement into the systems that we rely on. That's the pivot to make next. Move from reactive patching to design-driven reliability, model-driven reliability. So reliability starts at design time. How do we fix this, right? So we need to shift from reactive to design-driven reliability. Think of design by trust, the way we think of security by design or privacy by design. We don't just bolt these on, right, after we deploy. We build it in as we're designing the systems and as we write the code, right? And data modeling is no different. When we talk about modeling for reliability, I want you to think in 3 layers. First is conceptual. What is the thing that we're modeling? What does it mean? The second is logical. How do these things interact and relate to each other, right? And finally, there's physical. How are we implementing, storing, and validating this data and the meaning behind it? And when those 3 layers are aligned, trust naturally emerges. And when they drift apart, trust falls apart, right? And we've all felt this drift. We've all felt it. A product team might change definition, not tell anybody. This happens. An AI team reuses a data set in a new context. Maybe it's not appropriate for that. A pipeline team renames a column, maybe unaware that half the company depends on it. And reliability doesn't just fail at runtime. The important point of this discussion is reliability often fails at design time. In the moments we skip defining meaning, right? And this happens all the time. So how do we model as the foundation of trust? Well, let's make this trust by design more tangible. So modeling is the translation layer between how humans understand the business and how machines execute it. So when the story is clear, right, the system is reliable. And why modeling creates reliability, modeling makes meaning very explicit, both to humans and to machines, right? So ambiguity becomes decisions, not just happy accidents or unhappy accidents. Modeling turns expectations into constraints. And so the rules move from people's heads into the system's guardrails, into the AI's guardrails as well. And modeling shortens incident recovery. When failures happen, modeling the meaning means you can point to causes pretty fast, right? Because you know what you're looking for. And again, let's go back to the 3 lenses, right? You can use these tomorrow, right? So you have your vocabulary lens. Again, this is the conceptual layer, building a short living glossary for the few concepts that drive 80% of the decisions, right? Typically, they're customers, accounts, orders, products, active customer, churn customer. What's a refund, right? For each, capture the definition, examples, anti-patterns, and the ownership, right? So, and add a gotchas line, gotchas. What this term is often confused with and how to disambiguate it in the prompts and the queries. Then you have a structural lens, right? This is a logical layer to draw the minimal entity relationship map that your critical use cases depend upon, right? And probably keep it to 1 page. It doesn't need to be that complicated. But for each relationship, state the cardinality, right, and the invariance of this data, and translate these invariants into maybe constraints and tests. Tests for uniqueness, tests for nulls, tests for reference integrity, tests for allowable state transitions in the data, and so forth. And then there's the enforcement lens. It's the physical layer where the data is actually stored. Choose where each rule lives. Maybe it's in the source systems. Maybe it's in a contract. Maybe it's a CI check, an assertion, a feature store, whatever, right? The AI tooling layer. And try to enforce these things early. It's cheaper to reject a bad event or bad data than to fix 1,000 downstream artifacts. Attach lineage and metadata to every enforced rule, like who declared it, when was this declared, where is it checked, which assets depend on this, right? Again, we're talking about multi-case, multimodal data at this point. There's a lot of dependencies. Let's look at a miniature case, right? The active customer drift symptom that we talked about. The dashboard says growth, the AI assistant says decline. Maybe the root cause of this is you have two valid but different meanings of active customer. This happens all the time. Try it in your own company. Ask what an active customer is, right? So how do you fix this? At the conceptual layer, define the active customer. Is it somebody that's created, a customer that's been created in the last 30 days or created a second time? Maybe you have an engaged customer. That's somebody you sent a message to in the last 30 days. For the logical layer, you want to make sure that one order belongs to exactly one customer. That should work, but engagement, that maybe that's a second, maybe it's a first class entity linked to a customer and a channel, right? So understand these definitions that you're using and be very explicit about it. At the physical level, right? Have contracts that enforce distinct fields like active in 30 days, engaged in 30 days. This metrics layer underpins every concept that each KPI will use. And AI retrieves this data and uses it in its proper meaning, right? Once it knows explicitly what it's supposed to be. And the result is, one chart, one prompt, one truth, right? And so the AI explains a distinction instead of just making one up, like it tends to do. And these modeling patterns, right? This raises the trust of the data in the systems. You have names with semantics. So prefer to use explicit attributes in your data, right? Don't go for vague ones. Have good metadata as well, metadata that describes the top level data. Create thin slice conceptual data models. These might capture just enough shared language that de-risks the decisions that you're making with the data. But make sure people know about what this means, right? Adopt a constraint first design. Start from the invariants and then choose structures that make constraint violations almost impossible. You might have them, but it's something you need to design for up front in your data model. Take a constraint first design as well. Start from the invariants of your data, then choose structures that make violations harder to do. Let's see what else we got here. I mean, there's some other things that come in mind. Metric spec, name, definition, grain, filters, dimensions, who owns it, what's the change policy, right? This needs to live next to the code that computes the data and transforms it and so forth. And we're entering a new world too of what I'd call prompt-aware modeling, right? So you need to surface canonical definitions and constraints in your AI context window. Teach these systems to use the same words that the humans use. You can do this with semantic layers, knowledge graphs, ontologies, and so forth. But be very explicit about how you're modeling data. That's because data right now is used not just for humans; it's used for AI. That's the reality of it. So maybe some anti-patterns, right? That maybe erode trust. Adding columns without updating the meaning or constraints happens all the time. Having a catch-all entity in your data model, right? So generic events or properties that have no typed relationship or just could mean a number of things. Copying, pasting metrics, this is a big one where you're not explicit about the meaning. You're just probably being lazy and redefining KPIs or metrics, and tools, and not sharing these amongst your organization, amongst the tools. Data contract theater. I think this is a big one. Data contracts that exist but fail the build. Don't fail to build when violated, actually. So I think that's a big one where we're talking about, having, supposed checks and balances in place, right? But these things are never enforced. So what's the point of it all, right? So you think you're doing the right thing, but you're probably doing nothing at the same time. And that's demoralizing, right? And that doesn't build the trust by design that we're looking for. So you should be able to answer at any time, like, what does this term mean? Who owns the term? Where is it enforced? And what breaks if this term changes, right? This metric changes. So your warehouse, your feature stores, they should reject impossible states and not just flag them for later, right? So this means your dashboards, the SQL underpinning them, the AI assistants all resolve to the same model definitions. So incidents, right? They cite the violations, maybe. And so this means that modeling is not just paperwork. It is the operating system of the trust of your system again. So you need to get the story right, turn it into structure, and make the structure basically uncheatable, right? Unbreakable. This is how reliability becomes the default. So let's talk about something called the trust stack. When I talk about reliability with companies, this is kind of a new term. This is kind of prompted by this talk actually, but this is what I call the trust stack, and a simple way to visualize how all these layers, again, the conceptual, logical, physical, fit together from design, and on is through this trust stack. So let's first, the first layer is to model, right? Let's define what is true, right? So this is your foundation. It's how you define the world, right? Again, the entities and the attributes and relationships and the constraints. If this layer is fuzzy, I would say everything above it will start to wobble, right? Especially with AI. This means modeling your knowledge in maybe a knowledge graph, a feature store, an embedding space, ontologies, and so forth. These are all models of meaning, and not just the meaning of data, but of the context of the data. Again, context is becoming very key. The second layer is metadata, right? So describe how the data is produced. How is truth produced? Metadata is a connective tissue of trust in the data. And so metadata tells us how and when and by whom the data was created and transformed, and maybe why as well, right? So without metadata, AI becomes ungrounded. And with metadata, we can trace every data output back to its source, and even across different data modalities. So you need to think of the metadata as your trust lineage. It's how you prove that your data and your data model didn't just make something up randomly, right? So, and finally, layer 3 is monitoring, right? So you need to detect when the truth breaks. Observability is very essential, but it comes after modeling the data. And you can't just monitor meaning you've never defined, right? So monitoring works best when you're checking it against the modeled expectations. So therefore, a customer must have an email. A product must belong to a category, right? So this is being proactive and not reactive. There's another layer of meaning, right? Ensuring that people agree on what the truth means. And you might soon lump AI into that as well. But this is a layer we ignore most often, the human layer, actually. So this means having, data dictionaries, glossaries, a shared language. This isn't just governance theater. This isn't just paperwork, right? This is how you establish trust protocols with the people who depend on the data. And because every technical failure is ultimately rooted in the people process technology spectrum, people and process sort of breaks down. And every reliable system begins with a shared sense of meaning. It should be table stakes, right? But and finally, let's talk about modeling, beyond databases, right? So what does this look like in a multimodal world of AI? This is where the world is going, right? We're moving from databases to maybe data verses and so forth. So we're moving from rows and columns to text, images, video, voice, vector embeddings, AI agents. And these AI systems no longer just consume SQL tables, right? They're consuming other forms of data, right? Other representations. They just might be tokenized. They might be embedded. They might be vectorized, whatever. But so what does data modeling mean in this AI world? It still means that you're defining entities, relationships, and meaning, but now across different data modalities and use cases. So a product isn't just a row. It's also text descriptions, reviews, photos of the product, and the embeddings that link all these together. A customer isn't just an ID anymore. It's the behavior, the sentiment of that customer, and so forth. And, documents are not just text, they're structured, unstructured data. Maybe these are tied together by context. And so modeling for trust in AI, it means aligning the semantic space and the meaning of the semantics with the data space. This is new territory for everybody. And so your AI doesn't know the difference between two meanings of, say, a customer unless your model does, right? And so the key is to treat every AI input and output as a modeled object with lineage, metadata, and semantics. And so that lets you verify and explain and reproduce the AI behavior for the new So this is kind of the new definition of reliability, in my opinion. So we used to model systems for consistency, and now we need to model them for interpretability and for meaning, right? So reliability in AI isn't just does the pipeline run. Now I think it's also about does the output make sense, and does it create actions that provide better outputs and outcomes for us? And so let's kind of want to close on something else too, the culture of trust, right? So you can't design for trust if your teams don't trust each other, right? So this is going to be, I think, more painfully acute in the age of AI. So every unreliable system I've seen has a social reliability problem underneath it, right? A lack of ownership, communication or shared understanding. So, and this means data contracts aren't just YAML files, right? They are, but they aren't. So they're also, you can think of these as human contracts between producers and consumers, right? So these encode expectations, responsibilities, and context. And so organizations that understand this, I think, are going to treat data modeling as a collaborative effort and not just as a whiteboarding exercise. So this means engineers, analysts, ML practitioners, AI engineers, product managers, executives, you're all contributing to a shared definition of reality, because again, the AI is pervasive now, right? It's pervasive. And this is how humans are going to collaborate with each other. So you don't just model data anymore. Again, you're modeling trust. Let me just leave you with this final thought here. And again, it's a bit of a reiteration here, but we're entering a world where AI systems will act before we do normally, right? They'll summarize our knowledge. They might recommend actions to us, but I think more importantly, they're going to take actions on our behalf and maybe negotiate on our behalf and so forth. And again, it's where this all hinges is whether or not the underlying data and how the data relates to other data, how this was modeled for trust. So again, reliability isn't just about having perfect data. It's also about predictable behavior of systems and between systems. It's about systems that fail transparently, gracefully, can self-heal because they were designed to. And so if you're building the next generation of AI systems, don't just ask, what data do we have, right? No, just throw it into like one big table like we used to in the modern data stack era, but start asking, like, what does the word trust mean here, and how will we model it? Because when we model clearly and with intention, our systems become trustworthy. And when our systems are trustworthy, our AI becomes reliable. And when AI becomes reliable, the future stops being scary, right? And AI becomes useful. And I think we become more useful to each other. And essentially that is trust by design. This is what it means to model reliability into your data stack. So anyway, thank you very much. Model for reliability. Take care.